Okay, so please feel free to turn off your cameras if you don't want to be recorded, because we are going to post this session on our YouTube channel, youtube.com/@RLadiesRoom. We do this to ensure a safe, inclusive, and harassment-free space, which is our priority. We are committed to promoting a respectful environment where everyone feels welcomed to learn and feel to learn, to connect and grow. So please remember that all our attendees are expected to adhere to our code of conduct. You can find more at rladies.org/coc. And please feel free to use the chat again for introducing yourself, say where you're from, say hello to the others here that joined us. And as well, raise your hand if you'd like to ask questions or put just the questions in the chat. We are happy to welcome you to our November's event. Just a little introduction about the theme. It's Federica Gazzelloni, and a bit about my background. I am a statistician and an actuary, and so in general, an independent researcher. I do various type of collaboration and consultant. I'm a consultant, and also I'm a book author. And I enjoy organize this workshop, tutorials, introductions, and things for Our Ladies Room. I'll pass the word to Raffaella very briefly. Raffaella is our co-organizer. I don't know if you like to.
Hello, everyone. It's a pleasure to have you all here. I'm Brazilian. I have 25 years old, and I am working with cardiovascular disease. That's it.
Thank you very much. We also have other organizers in the team, but for today, we just the two of us. Okay, so we are thrilled to have you join us today. So get ready for an engaging, informative experience. Just to give you a bit more a sense of what's going to happen today. This is a session where Nicola will guide us through creative and technical process behind building impactful visualizations in R using ggplot2. So you learn how to move from data exploration to polished communicative graphics, build and refine a complete chart in ggplot2 from sketch to final design, gain practical tips and balancing aesthetics and clarity in your visual storytelling. Finally, explore strategies for translating ideas into effective data visuals. What is a bit more about us? So what is RLadies in general? RLadies is now it's a global organization. It's a no-profit organization. It's a global community with the mission of promoting the R language at all user levels by building a collaborative network. It is a friendly community founded in 2012 by Gabriela De Quieros. And since then, so has grown a lot. So there's many chapters all around the world. Our Ladies Room is one of these local chapters, just to tell is in the R language. And it is dedicated promoting inclusivity in the R language community and lifelong learning. Okay, our monthly meetings provide a platform to discuss current trends and hot topics, in particular in R, but we don't deny that we like to learn other languages such as Python. Okay, so just a bit about Our Ladies Room in numbers. Let's put this on a side. You can visit our website. We will be pleased about that. So please visit ourladiesroom.org. RLadies Rome has grown into a widely recognized community. So we have some visuals for you to see our reservation, how they grown along the time. And here is a bit of an overview of what are the most exciting events that we have hosted along the time. So please join us more and stay tuned for next events. What is this RLadies Rome team? At the moment, we are the three of us. We were like four. There were some exchanges of people coming and go, but that is one of the most important things, is that we don't ever leave effectively. So we are entirely volunteer team, a team of volunteers, and so we don't get paid. We do this because at our free time to allow people to learn for free, have an introduction of topics, and at this purpose, if you like to propose or a talk or being a future speaker. So this long, this long link I'll put in the chat. For you, it's just like a sort of, it's an Excel sheet where you can put your name, your email, if you like to be a speaker or join us, just give suggestions and whatever. So we'll keep in touch. What about next events? So just to give you an introduction about what is happening within RLadies Rome, so the art community in Rome. We have funded the Rome Art Users community, and so next month we will be hosting Jakub Nosat, which is quite a name. So he's one of the authors of Geocomputations with R. And you can see the website here, geocomx.org. And so he's gonna give us some interesting clues about spatial data. So please don't miss this one. We will provide more information soon. Well, so it's time for passing the word to our speaker. We are glad to welcome Nicola Rennie to RLadies Rome for this inspiring talk on ggplot2. Dr. Nicola Rennie is a data visualization specialist, but not only that, with a background in statistics and data science. She is much more. So she's a professor, she's a book author, she's a very good speaker. She's also author of The Art of Visualization with ggplot2 and a co-author of the Royal Statistics Society's Best Practices for Data Visualization Guidance. Nicola advocates for open source tools and effective communication through data. So without further ado, I pass the word to Nicola.
Thank you very much. I will just start sharing my screen. And hopefully you can see that. Okay, so welcome to the session on developing your data visualization skills in ggplot2. As Federica said, I work as a data visualization specialist. I use a combination of R and a little bit of Python, and more recently some D3 to make some more interactive charts. I have built quite a few R packages over the years, and most of those are for visualization. And quite recently kind of finished working on a book about visualizations with ggplot2. So what we're going to do in this session is walk through the process of creating a chart with ggplot2 from start to finish. There will be some little bits of sort of data viz design theory to help us sort of build a good chart. There will be some R tips and tricks to improve your charts, some sort of ways that you can make things better quite easily. And the whole idea of this session, I want it to be about sort of showing the process of building charts and designing charts, not just sort of give you some code and a chart we're going to make. So during the session, you are very welcome to code along beside me. I'll be doing quite a lot of live demos in RStudio. When it comes to the live demos, there'll be links to some code. So if you don't want to sort of code along and type it all out, you can copy little code chunks and run them and sort of play with them as we're going through it. Alternatively, you can just sit back and relax, enjoy, don't feel like you have to sit and write code, especially if it's after a long day at work. Do ask lots of questions. So we'll take sort of lots of little breaks from slides and demos to answer any questions you have in the chat, and hopefully there'll be time for some more questions at the end. Okay. If you do want to follow along to access the code and look at the slides, there's a link in the chat. Okay, but it's basically if you head over to my website, there'll be a link. If you even just type in talks, you'll find the slides online there. Okay, so if you can access the slides, that'll give you access to all the code and stuff as well during the session. Okay, so what I want to mention sort of before we get started, because this is where the data is going to come from, is something called TidyTuesday. If you haven't heard of TidyTuesday before, it's fantastic. So it's basically a weekly data project, and a new data set gets uploaded every single week. And people are kind of encouraged to make something with it. It might be a chart, it might be a dashboard, it might be fitting some sort of model, and then share the code and the output, usually through social media channels. And this is something that I participate in most weeks. And it's a really good way to just learn new skills, to kind of have fun with data and kind of learn new things in a low pressure environment. So we're going to be using some of the TidyTuesday data today. We're also going to be using these packages. Okay. I will go through each of these packages when we come to use them and sort of explain what each of them does. Okay. But if you are sort of following along, you will need to make sure you have these ones installed. Okay, so we'll be using quite a few of the Tidyverse packages. Okay, the other ones you might not have seen before is something called Camcorder. Okay. So I'll go into a bit more detail about that later, but it is sort of for viewing your plots at the right resolution in RStudio. We'll also be using ggtext for some fancy text rendering, show text for dealing with some fonts, and we'll be using a TidyTuesday R package to get the data. Okay. And the session will be demonstrated in RStudio. If you're using something else like VS Code or Positron, it'll obviously look a little bit different, but everything should still work, hopefully. Okay, so let's start by having a look at some data. Okay. So we're going to have a look at our TidyTuesday data. So each week you can access the data, and most importantly, I guess, a README file on GitHub. And that README file explains a little bit about what the data is and what the different columns mean, and it's a really useful thing. So for these examples, we're going to use a data set from 2023. Okay. So you usually get a little bit of information about what the data is and where it came from. Okay. You get some instructions about how do you load the data, and you get these data dictionaries that explain what each column is, what type is it, and a little bit of description and notes around it. Okay, so this data is data on pet cats. Okay, so basically they stuck a bunch of GPS trackers on lots of different cats, and there's two different data sets. One is a sort of an ID table of all different cats, so it gives you lots of information about them, and the other one is this sort of geographic data, so it tells you at where was that cat in terms of latitude and longitude at different points in time. Okay. So that's the data that we're going to be looking at. Okay. So the first thing we're going to do is load that data using the TidyTuesday R package. And this is one of the things where I do copy and paste it every week, so that is exactly what I'm going to do now. Okay. Again, nice thing about the GitHub repo is that you can take this code here, head over to RStudio, paste it in, and then run it. Okay, and it will load in those data sets for you. Okay. it sometimes takes a little while. This is quite a big data set, so it's downloading those and taking a little while. Okay. With the demos, if you want to be running the code yourself, okay, so if you're on the slides, if you click to expand the code, there's a little button in the top right of the code block. Okay, you can copy and paste the code and then run it and play with it. Okay. If you do run into any issues with running any of the code, do just stick a message in the chat and we'll try and fix it. Okay. So this first line of code loads the data into R. I will share the GitHub link. Good one. You can get it from the slides as well, but that's the GitHub link. Okay. So this first line of code downloads all the files you need, and then you can access them through that sort of Tuesday data object. Okay, so we have our two data sets. You can see them here. So our reference data is quite a small data set. That's our lookup for the different cats and information about them. And then our sort of cats UK data is all of our geographic data. So there's a lot more observations because there's different rows for every time period. Okay, so we've got our data. Now, we need to figure out what we're going to plot. Okay, and so we want to start thinking about what question are we trying to answer. Okay, now quite often with data analysis projects or statistical projects, the idea is that you start with a question and then you go out and find the data that helps you answer that question. When you're doing things like TidyTuesday, that kind of happens in the opposite order. So you have a data set and you have to sort of figure out, what's interesting about this data set. So what are the specific questions that you could ask? And then what you often want to do is do a little bit of exploratory analysis and try and figure out, are any of the answers to those questions interesting? Okay, so some of the questions that you might want to ask for this data is like, where do cats go? Do they go really far from their house? How fast are they traveling? Do they spend a lot of time indoors or are they outside? And how does that change based on their age, for example? Okay, so these are all questions that we could answer with the data that we have. So what I usually do first is try and explore some of the variables. Okay, look at the different columns, have a look and see whether that data's suitable for kind of answering these questions and which one might actually be interesting. Okay, so I'll jump back over to RStudio. Okay, do let me know in the chat if that the font is too small or anything, and I can make it bigger, or if you'd prefer it on light mode for viewing through Zoom. Okay, so one of the first things I tend to do when I have a data set is look at it. Okay, so you can either, if we start with the reference data, is you can look at it in the console. Okay, my console is in the top right because it makes it a little bit easier for sharing. Okay, but you can see here's lots of information. What variables do we have? And you get a little bit of a feel for the data. You can also use the view function in R, okay, to again look at that data. Okay, so you can scroll through it and see if there's anything that looks unusual, okay, or any columns that are going to be, I guess, not very useful. Okay, so what you might notice is this third column. Okay, this tells you about the animal taxonomy. Okay, so what species is it? Well, they're all cats. Okay, so straight away you can kind of see that third column is going to be pretty much useless for our analysis. There's no variability in it. Okay. And then we can start having a little look at some of the different columns and the different relationships that might be in the data. Right. So I know this was advertised as a ggplot2 session. I'm going to be a little bit controversial and start with my exploratory plots in base R, right? And the reason I always still start with stuff in base R is just because it's quicker. Okay? It's always going to be quicker to just type out plot, whatever it is, rather than setting up that ggplot2 notation. Okay, so these sort of exploratory plots, they don't have to look pretty. You literally just want to see the data. Okay, so I'm going to have a little look, first of all, at the latitude and longitude data. So if we do Cats UK, and then look at the location longitude first. I always get confused between latitude and longitude in terms of X and Y. Okay, so we have, let's just make essentially a scatter plot of longitude and latitude. Okay, and you can see in the plot window, okay, there we go. Okay, so this is all of the cats and all of their GPS locations at sort of every point in time. Okay, so you can see there's lots of little clusters. There's sort of one point that's really far away. It's quite hard to tell with this example, sort of what the without the spatial background and without knowing what cats there are. Okay, but you can see quite a few clusters, and there might be something interesting there. Some of the other questions we looked at is things like how fast the cats run. So one of the uh, columns that we have in the GPS data is the sort of ground speed of a cat. Okay, so on average, how fast are they moving around? So what you can do is you can do a histogram of that. Okay, um, okay. So we can look at ground speed. Okay, and you get this. Okay, which is generally not what you want to see when you look at a histogram. Okay, it's very, very skewed. There's lots and lots of little values and maybe one or two really big values. Okay, um, now one of the things to think about when you're looking at the data is again go back to that data dictionary on GitHub. Okay, so what's the ground speed actually measured in? Okay, so here it says the units are meters per second. Okay, um, 250,000 meters per second is very, very, very fast. Okay, so this is maybe an indication that this isn't a column in the data that we want to be working with because maybe it's not very sort of trustworthy. Okay, this is like I think it's like tens of thousands of miles per hour. Um, cats are fast, but they're not that fast. Okay, so we might want to look at some other columns. Okay, and look at, for example, how long do they spend indoors, right? Um, and we might want to look at how that changes as they get older, right? So again, what we could do is we could plot that uh, here, okay? So this is going to be reference data this time, so looking up just the information about the cat's age, okay? And then on the y-axis, we'll look at how long they spend indoors. Okay? And you get a chart that looks a little bit like this. Right? And so, okay, maybe it's a little bit hard to tell from these exploratory plots whether there is there a relationship between those two things. And if you start looking at the data in a little bit more depth, if you counted up all of those dots, there's not as many dots as there should be. Right? So if you look at the number of rows in our reference data, okay, there's 101 rows, and if you count these up, there's not 101 dots. Okay, and it's because these are all categorical variables. Okay, so you'll notice that the points are sort of appearing in rows. Okay, so although this is hours, there's actually just 5 categories, and the years are given in whole years rather than sort of with months. Okay, so there's lots of points on top of each other. So if we wanted to really visualize this, we might need to think about doing something like a bubble chart. Okay, so where the size of the points changes based on the number of things in that category. You could do something like a heat map. You could keep working with the points, but maybe add transparency. So darker points mean there's more sort of cats in that combination of categories. Okay, so this is a nice starting point. Okay, and we know that we have the data to explore this relationship. And we want to start thinking about different ideas of how we could explore this relationship a little bit more. Okay? And this is the point where I think a lot of people jump straight into okay, I know roughly what kind of plot I want to make. I'm going to jump straight into ggplot2 and I'm going to make it. Okay. What I would say is don't jump straight into writing code for that final chart just yet. Okay. Sketch out ideas first. Okay. Sketching is a really important part of the design process. Okay. And whether that's on pen and paper or whether it's in, like on a tablet and it's kind of digital drawing, like a pencil on the back of an envelope, whatever it is, it's a really good way to explore different visualization ideas. Okay? In the same way that we've just explored the data before we decide how to process it, we want to explore ideas um, for visualizations. Okay? And you can refine those ideas and you can throw them away if it doesn't work. Okay? Sometimes if you jump straight into writing lots of complicated ggplot2 code, it feels a little bit difficult to throw it away if you don't love it because you've already sort of invested a lot of time in it. But if you just start off with like a really quick, really rough sketch, if you think actually, nah, I don't like that, just throw it in the bin straight away. Okay. So you might start with the kind of bubble plot idea, okay? Or you might sketch out a heat map. And again, it's kind of a very rough idea, and you can think, okay, maybe what I'll do is I'll figure out what text elements do I want to add some annotations, and just sort of sketch those out first. Okay? So then once you have that kind of final sketch, then you have something that you are specifically trying to build in ggplot2. So it's separating out that design of a visualization from the code a little bit. You could take this sketch and go make it in absolutely any software you like. Okay? But let's start with some ggplot2. Okay, so what we're going to do is we're going to start off with, let's do a little bit of data wrangling to make sure our data's in the format that we need it to be. And then we'll build a sort of very basic plot. Okay, so let's jump back to our studio. Okay, let's give ourselves a little bit more space. Okay, and do some data wrangling. Okay, so what we need in order to make a bubble chart is the age, okay, the number of hours spent indoors, and a combination of the number of cats in each combination of those two things. Okay, so let's start by just grabbing the columns that we actually need. Okay, so this cat's reference data has a lot of columns in it, and to make this chart, we don't need the vast majority of them. Okay, so I tend to just at this point start dropping columns that you don't need, because it makes it just nicer and cleaner to work with. Okay, so I'm going to use the select function from dplyr to keep just the columns I need. Okay, so we'll do age in years and then hours indoors. Really helps if you load all packages first as well. So load dplyr and tidyr as well. Okay, you can just load the whole tidyverse if that's easier. Okay, so if I select that, I have just these two columns. Okay, so one of the things that we might want to be a little bit careful about is this hours indoors column. Okay, so right now when you look at it, you can see that it's listed as a double, so it's kind of like a numeric column. But our exploratory plot tells us actually it's more of a category, right? There's only 5 possible options. There's not essentially infinitely different values. So what we might want to do is convert that hours indoors column to a factor first. Okay? So we can do hours indoors is a factor of hours indoors. Okay, and when we run that, it's not going to really look any different, but R sort of knows actually that's a category. Okay? So then we want to just count up the number of cats in each combination of category. So we'll look at age and hours indoors, okay, and use the count function from dplyr. Okay, that counts up the number of unique combinations. So we now have a third column, N, which tells you for this combination of age and hours, how many cats are in that combination. Okay. Sometimes it's useful to have, at this point, another little look at the data using the view function. Okay. And if you scroll down to the bottom here, okay, you can see there's an NA value. So there's one of the cats doesn't have an age listed. Okay. I'm not going to go into the depths of missing data at this point in time, but for this chart, we're going to drop that row of data. Okay. So easiest way to do that is use the drop NA function from tidyr. Okay. And this is all the data that we need to make that kind of bubble chart. Okay. So I'm going to save this as plot data. Okay. So if you look at a lot of my code on GitHub, you'll see that I do this kind of quite often. I always end up calling it plot data, and it's sort of like, this is the data that I need to make the chart. Okay. And again, it's another way that if you want to do something like data processing in R, but for whatever reason visualize it somewhere else, you know that you can export this plot data as a CSV file, and that's everything you need to make the chart. Right. So let's make a chart. Okay, so we'll start by loading ggplot2, and then we almost always start every ggplot code with the ggplot function. Okay, and it takes two different arguments. Okay, so we can set the global data source. Okay, so if we have multiple layers in our plot, we might want to use multiple different sets of data in our plot. Here we just want to use one. So I'm going to set data is equal to plot data. And I'm also going to set the aesthetic mapping. Okay, so the aesthetic mapping, so it goes inside that AES function. Okay, and that essentially tells ggplot which variables are going, for example, on the different axes, or which ones are being mapped to color. Okay. So we'll sort of essentially start by recreating this plot here, okay, that we made in base R, and say X is equal to age in years, and Y is equal to hours indoors. Okay. Now, if you run that code, you get essentially a blank plot, but with the axis values. Okay. Now we want to add points, so we're going to use geom point. Okay. And you essentially get a remake of that chart with that we previously had in base R. Okay? But we did talk, instead of just using points, let's kind of make it a bubble chart where the size of the points relates to n, the number of cats. So here we can add another aesthetic mapping. We can do size is equal to n. Okay? And that gets us our bubble chart. Okay? Now what I'm going to do here is I'm going to save this as our sort of base plot or basic plot. Okay, so I think this for me is one of the really nice things about ggplot2 is that you can save plots as objects and then go and manipulate them later on. Okay. It's a nice way to sort of break up your plotting code. Okay, I'm sure you've all, I mean, I'm guilty of this as well, but seen some ggplot2 code and it's just really, really long and complicated. What you can do is basically do little chunks of it at a time and save different objects. And that's what we're going to be doing here. So I think, yeah, we want to jump back to the slides and have a little think about what do we want to change about this chart. Okay, so we've made a bubble chart in ggplot2. Okay, a very basic sense, we've made, you know, that we've made the chart, right? So some of the things we might want to change about this are like the styling. Okay. I'm not a huge fan of the grey background. So we might want to change that. We're going to want to add some better axis labels and our sort of title and subtitle. Okay. We talked about doing things like adding annotations. So maybe we want to highlight some of these interesting sort of outlier points. The other thing we want to change is going to be this legend on the left-hand side, on the right-hand side. So as soon as you map anything to, if you map any variable to something that isn't just an axis, you get a legend created by default. Okay, and here n is numeric. Okay, so R just kind of tries to make them equally spaced. Okay, the problem is that the values in this legend are entirely implausible. Okay, n is the number of cats. You cannot get 2.5 cats. Okay, so we want to be choosing values in that legend that are a bit more sensible. But before we go any further, I want to talk a little bit about plotting resolution. Okay, so if you've ever spent a really long time, perfecting a plot in with ggplot2 and sort of, previewing it in this plots tab um, in RStudio, and you think, that looks brilliant. Okay, I'm ready. I'm going to use ggsave to save myself a nice high resolution copy of that I can put in a paper or presentation, and then you save it, and it just comes out looking absolutely horrendous. The font sizes, the point sizes, are just absolutely everywhere, and it's not a nice feeling because you spent a really long time making it look nice. Okay? So the reason that happens is because when you look at charts in this plot tab in RStudio, they're at quite a low resolution. Okay, so it's 96 dpi, so dots per inch. Okay, but when you use ggsave, that saved at a much higher resolution, so it's saved at 300. Okay, so some things get stretched or squashed. So, I mean, I guess the easiest way around that is you could set the dots per inch to 96 with ggSave, and it will save exactly what it looks like in RStudio. But you don't usually want to save a low resolution image, right? So what we actually want is to preview the chart in RStudio at the resolution we're going to be saving it at. Okay? And there are a couple of ways to do that. So the way I usually do this is with the camcorder package. Okay, so what the camcorder package does is um, instead of you viewing your charts, previewing them in the plot pane, it's going to put them in the viewer tab. Okay, and it's going to show them at a resolution that you choose. So you can set it to the same thing used by ggSave. So that means basically what you see in this tab will be what you get when you save your plot. Right? The other nice thing about Camcorder is that it automatically saves an image every time you make a plot. So you kind of have a record of every image you've made, and you can make a little GIF of those image files so you can sort of see how charts were built. Okay, and that's kind of a nice little free thing that you get as well as previewing charts. Okay, the only thing I would say about Camcorder is unfortunately it seems to be a little bit broken with the most recent update to ggplot2. So if you are using ggplot2 version 4.5, very recent release, you might find that Camcorder doesn't work quite the way you want it to, unfortunately. So a sort of workaround for that at the moment is to use this ggview package. Okay, so again, you can preview your ggplot2 output directly in that tab in RStudio, and you say what resolution and what size do you want it to be. Okay? You don't get the little GIFs, but for the purposes of what we need, if you're using a really recent version of ggplot2, then you can use ggview instead. Okay? I'm going to use Camcorder because I like it. So we load up the Camcorder package, right? And then we set GG record, right? And you'll see there's a lot of options here. The default resolution, so if you actually just look at the help files for it, you can see that the default DPI is 300. that matches ggSave. Okay, so it's kind of the defaults are set up to work with uh, ggplot2 really nicely. But what you can do is set a width and height. Okay, so by default in R, stuff tends to just fill the plots pane. It goes whatever size you want, and every time you drag it, the aspect ratio kind of changes. But what you can do is just set the width and height. Okay. You do get this sort of little warning message here if you've run this before, which apparently I have. Okay. So we've set up camcorder, and so we're ready to go ahead with some more advanced styling and think about what is it that we want to change with this plot. So the first thing, or one of the first things we're gonna have a look at is colors. Okay. So how do you choose good colors? Okay. There's, as you can see, sort of default gray backgrounds, sort of gray panel background against a white background, and we've got these sort of black points, and it's like it's fine, but it's not particularly pretty. Um, and there's also sort of if you were mapping a variable to colors, there's a sort of default bluish sequential palette, um, or some like salmon pink and green palettes as well in ggplot2. But it's really useful to think about choosing good colors. Okay? So first thing I tend to think about is what's an appropriate type of palette. Okay, so you have sequential palettes that go, from light to dark or vice versa. You have diverging palettes which kind of get darker in two different directions. And you also have qualitative or discrete palettes. So you want to make sure that the type of palette you're using matches to the type of data. Okay, so if it's a continuous variable, it should probably be sequential. If it's categories, be qualitative. If it's, difference above or below an average, then a diverging palette works really well. Okay? And sometimes ggplot2, it tries to choose the correct palette, but depending on the way your variable is encoded, so is it a factor or is it a number, it might choose like the wrong one. So it's a very old website, but I still use it all the time. I quite like this color brewer site for choosing different color palettes. Okay, so you can have a look through, is it a diverging palette? You can choose only colorblind safe options, ones that are also print friendly. Okay, so does it print well in black and white? Okay, I'll ping a link to that in the chat if anybody wants to play with it. Um, so these color brewer palettes, there's some nice scale functions in ggplot2 that implements those. There's also an R package that implements it in base R. Okay? So it's a really old website. It's been around for ages, but it works really well. Okay? The other things you might want to think about are things like color associations. Okay, so if you're looking at something like a weather chart, um, red is usually hot and blue is usually cold. Okay, so you would never want to switch those around because that sort of association is so strong that people can get confused if you switch them around. We touched on making sure things are colorblind friendly. Okay? So what you want to be doing is checking, are the colors that you've chosen sort of, can everyone still tell the difference between different colors or different categories? Okay. And I really like this colorblind R package because you can throw in a ggplot2 object and it simulates what that chart looks like to people with different types of color blindness. Okay. Um, so you get something like this, right? And so this is showing you what does this chart with the default ggplot2 colors look like to someone with different types of color blindness or when you print it in black and white. Right? And you can see that these default colors are not such a great choice. In our chart, we don't actually need to map anything to um, a sort of any variable to an actual color. Okay, there's nothing, you could theoretically map size to color, so darker points are also bigger, but there's no need for that. Okay, we can just keep it simple and choose a single color. So one of the websites that I love is when you're choosing a particular color. This is taking a while. It's just okay, maybe. Well, that's disappointing. But have a look at the Coolers website. You can sort of flick through and try a whole bunch of different colors and choose one that you like. So let's create a slightly more colorful chart here. Okay. So one thing I really recommend doing is creating variables to store your colors in. Okay? Because there's going to be quite a few different things that we want to have the same color. And it means that, you would have to go in and type out that color multiple times. And then if you want to change the color, you think, oh, actually, it would look nicer like this, you have to go and change them all. Okay? But what we can do is we can create some variables for colors. Okay? In this chart, I'm going to use 3 different colors. Okay? So I'm going to use a color for the text. Okay? Um, the default is for some things black or a sort of dark gray, but I want to sort of make them all the same color, and I really want that consistency. So I'm going to create a variable called text color, and I'm going to make it a very dark gray. Okay, so it's not quite um, black, okay, but very dark gray. I'm going to create a background color. Okay, I'm going to use something that's slightly off white. Okay, so I'm going to use a very, very light gray for the background. Okay, quite often I start at this point making it a very light gray, um, and then at the end switch to making it white, and I'll show you why in a second. Okay, um, so I then want one more color that I'm going to use as a sort of highlight color. Okay, that I'm going to use for the color of the points and for any like important annotations that I want to draw people's attention to. So rather than using color to make it, bright and colorful, and sort of decorative, we really want to use color to draw people's attention to something specific. So I'm going to create another variable, highlight color, and I was hoping we could pick a random one from here. Let's see if this works. It's not working. Just okay. Well, let's see what color this is. The joy of technological problems when you need them. Okay. Okay. That's a sort of dark purple color. Okay, so you can specify colors either by colored names or by sort of what we call hex codes. Okay, so if you want a list of all of the colors that are available in R, if you type colors as a function, okay, that gives you a list of 657 possible colors that you could choose from that you can use as a name in R, or you can use a specific hex code, which is really useful if you're doing things like making like branded charts to match organization colors. Okay. So if I then view my base plot again, you're going to notice, hopefully, 2 things happening. Okay. So the first thing that's changed is it looks a bit bigger, but it's also now in the viewer tab. So we're now viewing it at that 6x4 300 resolution. Okay. And what you can see is this is very specifically a 6x4 chart. So if I make it taller, it doesn't stretch. Okay. But because the background is white and the color of the viewer tab is also white, it's really hard to see where the bottom of the chart is. Okay? So that's typically why we're going to use a slightly off-white background color, is so you can see how big the chart is. Okay, just kind of makes it a little bit easier to see the edges. Okay, so what we're going to do is we're going to update this basic chart code. So we're going to use the color of the points is now going to be that highlight color. You can sort of update the defaults that ggplot2 uses so that it will automatically use your highlight color for any points. I don't really like doing that because it sets them for the entire session. And that's a bit annoying. Unfortunately, there's no easy way to update the color of elements that aren't mapped to an aesthetic after you've made the chart, which I'm still sad about. Okay, so now our base plot, okay, we've got some dark purple points as well. The other thing we're going to do at this point is we're going to edit that legend. Okay? So you might be kind of familiar with some of the scale functions for working with colors. Okay, so things like scale filled manual or sort of scale color discrete. There are scale functions for essentially every aesthetic. Okay? So that includes size. So what we can do is set scale size. Okay? And remember, we don't want, half a cat. So we want to choose some nice breaks. And I'm just going to do it manually here and say the breaks are going to be at 3, 6, and 9. Okay? So the points change size ever so slightly, but most importantly, we have a legend that only has a whole number of cats in it. So let's think about some other elements of our chart. Okay? So let's talk about fonts. Okay? And if you talk to anybody about using fonts in R, they'll probably sigh and tell you how horrible it is. And it is often cited as being one of the really tricky things about making charts or visualizations in R. Okay? And it's not helped by the fact that there are lots of different packages for working with fonts in R. And if you Google or like use ChatGPT to try and get, how do I load this font in R, you will get a lot of different answers. And you'll probably get some quite old answers that don't work anymore, which is quite annoying. So in terms of which packages would I recommend, I think it depends what fonts you're using. Okay, so if you're using fonts that you have locally on your laptop, okay, so it's a font that's already been installed on your laptop, a combination of the RAG package and the system fonts package works really well. Okay. What we're going to use today is the show text package. Okay? And the reason I really like the show text package is because it works really well with Google Fonts. Okay? And that means that if you're sharing your code with someone else, they don't need to have the font installed in order for it to work. Okay? So what you can do is you can go and browse Google Fonts. And so you choose a font that you like. Okay. So you can browse through and choose lots of different options. Okay. So I tend to choose a, a sort of pair of fonts for visualizations. So I choose something that's quite plain and easy to read. Okay. So something like this default or like Open Sans works really well. I tend to use for my uh, plain sort of font, I tend to use Ubuntu. It works really well, and it's very accessible. So you can see that there's some little like ticks almost. It's not quite sans serif, okay? But letters are very distinct, and that makes it quite easy for different people to read. So how do we get that into R? So let's load some fonts. So the first thing we want to do is load that show text package. Okay. And then we're going to use the font add Google function, okay, which is actually exported from sysfonts, but you get it for free when you install the show text package. And the only argument we need to put in here is the name of the font. So you can copy and paste that from Google, or you can type it out. But when you run that, okay, sometimes takes a little second, but this loads that font in, so it's going to be accessible in R. Before we move on to the next sort of step, we're going to choose a second font. So I tend to choose something that's kind of more like bold or more fun for the title. Okay. You can use it for the title, but also any, again, annotations that you want someone to really look at. You want quite a bold, but still clear font. Okay, so you can browse through and look for different things. Okay, so you can choose something like a serif font that's quite bold. Entirely up to you what you choose. If you're making, when I choose things like fonts and colors, depending on the data, it's quite nice to make them kind of match the theme of the data. So it sits with it really nicely. So there's some, like if you're making a spooky plot for Halloween or Christmas, there's some nice fonts that kind of feel like that data. Okay. So the font that I am going to choose for this chart as my sort of title font is going to be called Chewy. Okay, it's quite a sort of fun font, I guess. Okay, so I'll just show you that. Okay, so it's this one here. Okay, so it's quite bold, it's quite a thick font, works really nicely for titles. So I'm going to do the same thing again and load that in. Okay, so the font add Google basically kind of loads the fonts in the background from Google into your session. What we want to do next is use the show text package to tell R basically how do you use fonts. So the show text package, you can use show text auto, okay? And that basically says by default, use show text to render fonts. And so it works really nicely with those Google fonts. The other thing that is really helpful with the show text package is the options. And what you can do in here is again set that DPI, that dots per inch, to 300. And what that means is that the text sizes, if you were saving it at a lower resolution or even higher, the text is going to sort of scale properly when you save it at different sizes. And I'm going to do a similar thing here as I did for colors and use variables for fonts. Okay, so I'm going to save my title font with the same name that I've loaded it in as. And I tend to call it like the body font. So it's the body of the chart or the document. That's what font you're using there. Okay. And again, that's just going to make it easier if you decide to change fonts at a later point in time. You can just change this line, rerun your whole code, and it will update to that new font. It's a really sort of nice, easy way to change fonts quickly. So we've got some fonts and we're ready to add some text. So we want to think a little bit about what text are we gonna add, right? Are you gonna add like a title, subtitle? What else is going there? So we've talked a little bit about the fact we want to add annotations. And what we could do is we could, just decide what our annotation is going to be and type out the text for those annotations. So like, the value of X at time, whatever is this value, manually type that out as a string and add it as an annotation. Okay, that's absolutely fine. Okay? But it's not like the best process, okay? Because it means you have to manually go and look up the values. So you're probably going to have to do some like summarizing of data or a little bit more data wrangling to get the values. There's quite a big risk of making a typo if you just accidentally type either the wrong number or put a comma in the wrong place or something. And you have to remember to update it if the data changes. So if if you make the same plot every month for like a sort of monthly report, or if you're sketching out your plot if and you get more data halfway through your analysis, you have to like actually remember or write yourself a note to go and update that annotation. Okay. So it's kind of fine for a one-off plot, but it's a bit annoying to just have to do it manually. So what we can do instead is make data-driven annotations. So again, there's a few different ways to combine variables, the values that variables take, with text in R. Okay. So you might have seen paste or paste zero in base R. Similarly, sprint F. What we're going to use today is the glue package. So it works kind of similarly to paste. It's vectorized in a nice way, and I think like the syntax is a little bit nicer and it feels a little bit more readable. So I tend to use glue for that reason. And that's what we're going to look at an example of. So we're going to make some annotation text. We're not quite ready to add them to our charts yet. We're going to make our annotation text ready first of all. Okay, so let's say we want to annotate this point here. Okay, this one in the top right, it's the oldest cat. So the first thing I need to do is basically find that row of the data. So I'm going to use slice max again from dplyr, I think, to get the age, the row with the highest value in age. Okay? So we have one cat here, okay, which is this one here. So what we want to do is we want to, in here, decide what is the label for that annotation. So I'm going to create a new column. There's a few different ways you can do this. You could just do it as, a variable rather than doing it within mutate. But I'm going to say the label is going to be equal to the oldest cat is, I don't want to put in the cat's name, who is some years old. Okay. So what I want to do using R is fill in these gaps with values from the data. So if we're using the glue package, we want to load that in. So you do library glue. And then we want to surround that annotation text with the glue function. And what this is basically going to say is glue together this text I've written with some variables. So what we do here is we replace our sort of gaps or our ellipses with curly brackets and then the name of the column that we want to fill in that gap with. Okay, so in this one is going to be the name of the cat, which is animal ID. And we do the same for the age here. So it's going to be age in years. And to make it a little bit easier to see, I'm going to just select, oh, not in there, select just the columns that we need. So again, it's going to be those hours and doors to help us position the annotation in the right place, the age, and the label. So if I run that, okay, you can see I have, these are the coordinates where I'm going to place it. I missed a word. Okay, it doesn't help those kind of typos. Okay, so you have the oldest cat is Boots, who's 16 years old. Okay, so that sort of sentence gets filled in a data-driven way. So if you updated your data set and you got an even older cat, or something happened to Boots, that label would update automatically. Okay, so I'm gonna save that as sort of annotation oldest, okay, annotation for the oldest cat. And then what we want to do is add that annotation to our chart. So we have our base plot, okay, which is on the viewer tab there. And we want to add text. Okay, so we start with geom text. Now by default, it's going to use that full plot data set, but we don't want to put the whole data set into geom text. We only want to add in the data from our annotation. So we're going to overwrite the sort of global data with our annotation data set. And we're going to put the mapping in again. It will still work with the overall aesthetic mapping, but I'm going to adjust it a little bit in a second. Okay, so I want to put age on the x-axis and hours indoors on the y-axis. Okay. And if we're adding geom text, we need a third aesthetic, and that's the label. Okay. So let's see what happens if we do that. Okay. So we're getting a little weird error message here. So the reason it's getting an error message is because it's trying to use size inside geom text. Okay, because we've got size in the sort of global aesthetic mapping here. So what I'm going to do is edit this and say our mapping is going to be just for geom point. Okay, so there's absolutely no change to our chart, but it means we don't get an error. However, we have created something that, doesn't really look like what we expected. Okay? And the reason this is happening, okay, you can see that it's really stretched that y-axis and our annotation is like way too high. So if we look at our annotation, all this, it looks almost correct. The thing that's different is that our hours indoors, if you remember, we converted it to a factor, right? It's not quite a factor yet in this data set. So we can either edit our annotation data or we can just sort of wrap it in here. It doesn't really matter which one at this point. So if we do that, okay, so we have something that looks a little bit better. Okay. I guess there's a couple of things wrong with it. Okay, first of all, it's sitting, I mean, we did ask for it, but it's sitting directly on top of the data point. Okay, so it's sort of hiding it. The second thing that's sort of wrong with it is it's running, off the chart area. You can't actually read the whole annotation because it's one really long line and there's not enough space for it. So what we want to do is wrap that text onto multiple lines. Okay, so it's maybe sort of 2 or 3 lines tall. And again, there's a couple of ways to do that. So one way of doing it is to use some of the functions in the string R package. So there are things like string wrap, and you can say each line can be no more than 12 characters long. Again, that's nice, but it sort of depends on you knowing like how many characters you want to split it into. Okay? And that's quite a bit of trial and error, and that might change if you use like a bigger font. Because it's not really the number of characters, it's the width is what you want to wrap based on. So you could mess around for ages trying to fix it. Or what you can do is use the ggtext package. Okay. So the ggtext package is probably one of my favorite ggplot2 extensions. It gives you lots of like really nice functionality for making nice annotations and working with text more easily. So instead of using geom text, what I'm going to use is geom text box from ggtext. And if I run that, okay, you can see that it's changed slightly. Okay? So our annotation is no longer just text, it's now in a sort of white text box with some rounded edges. But that text has wrapped a little bit. It is still going off the page, but it is automatically wrapping. So what we can do is we can change these parameters a little bit more to choose how much wrapping do we want there to be. So what you can do in geom text box is set the max width, okay, and that's what's the maximum width that your annotation can be. And you can set that in any unit you want. I'm going to use inches because we set the width and height of our chart in inches. Okay, it's 6x4. So I'm going to say this annotation can be no more than 1 inch wide. That, okay. I get something that looks much more kind of well wrapped and the right size. It's not quite in the place that I want it to be. Okay, so it's currently aligned to the data point on the left-hand side of the box. Okay, so our data point is like just under here. What we want to do is align that kind of more towards the middle of the box. So we can do h align is equal to 0.5. Okay, and that aligns the box and the text. Well, aligns the text within the box. H just sets the position of the box a little bit. Okay. It's still sitting on top of that point, right? And I mean, that's exactly what we've asked for. So what we actually want to do probably is offset it a little bit. Okay, and this is going to be one of the sort of manual fiddly bits. We probably want to take this box and move it left a bit. Okay, so it's going to be something like minus 2.5. Okay, so it's going to shift that along a little bit. Now, you can also edit the styling of this if you'd like. Okay, so you can, for example, make the font a little bit smaller. It's a little bit too big as it currently is. We also want to set the font that we're using to the ones that we specified earlier on. Okay, so we want to set the font family. Okay, so fonts in ggplot2 are usually specified with a family argument. So you can do family equals body font. Okay, and you can see that that makes it a little bit smaller, and it's using Ubuntu font. Okay, you can see it looks quite different now. We can also set our colors. So if we set color is equal to our text color variable, okay, it's a very subtle change. It changes both the color of the box outline as well as the color of the text. That might be what you want. You can set the box color to transparent if you want to. It's kind of entirely up to you. So we've got our annotation added. So let's save that chart as our annotated plot. Okay. So it's again saved as a variable, and we'll keep building on that, but it keeps our code looking a little bit nicer. So that's added our annotation, but there's still lots of other text elements that we could add to our chart. Okay. And in ggplot2, we tend to do that with the labs function. Okay. So in the labs function, you can add a title, a subtitle, a caption. Okay. There's another few arguments in here you might or might not have used before. Okay, so you can set the X and Y labels for the axes in labs as well. There's also an element called tag, which by default sticks like a little well, tag to the top left of your chart. So you could tag them as like chart A, B, C, and D, kind of like almost like a subcaption kind of thing. But the nice thing about tag is that you can set the position of it anywhere on the chart. So it's a really good way if you've got like a longer subtitle that you want to position somewhere else on the chart that's not just, top left. You can move that text around really easily. So I use that quite often if you're making sort of custom subtitles. You can also change the legend title within labs as well. Okay. So let's do that. Okay. So let's jump back to our studio and add some text to our annotated plot. Okay. You can just do annotated plot plus labs title equals and type your title in. I'm gonna again use variables to store that text in. Okay. A little in the same way that I've used variables for the colors and the fonts. There's no particular reason for doing that other than it keeps your chart code looking a little bit tidier. And we're again going to use a sort of data-driven subtitle. So it sort of keeps that data wrangling code out of the plot code a little bit more. Okay. I'm going to create a variable called title. Okay. Say, do older cats spend more time indoors? Okay, so kind of use a question, get people thinking about the chart. And what I want the subtitle to say is, well, around some percentage of cats uh, spend like at least 22.5 hours indoors per day. Okay, so again, I'm going to do this same sort of trick we did with our annotation here and use the glue function. Okay, so I'm going to create a variable called subtitle. Okay, that is our the contents of our uh, character string. Just move that another line. So I need to figure out what value goes in here. Okay, so I want the percentage of cats that spend 22.5 hours indoors. So we can get our catch reference data. You can do this, in a sort of tidyverse way if you want, or you can do it sort of base R way. I'm gonna, mix and match here. So we have all of our cats indoors data. So I want to know how many of those values are equal to 22.5. Okay, so if I do this, okay, I get this big true false vector. So the number of cats for which that is true, if I add them up, is 7. Okay, and so to get a percentage, I divide by the number of cats in the sort of entire data set. Okay, so I get 0.6. I want to format this, so that it looks nice in text. So I'm going to multiply it up by 100, and then I'm going to round it. Okay? And the reason I'm rounding it is again so that it reads nicely in a sentence. Okay? And then we'll just save that as a variable. Okay? And then we can update our subtitle, okay, to put our new variable that we've created in those curly brackets, okay, and that adds it to that sentence. So around 7% of cats spend at least 22.5 hours per day indoors per day. Okay. So we have our subtitle, and I'm going to add another variable for the caption as well. Okay. So caption is usually good for putting in the source of the data and the source of the plot. Okay, so we'll quite often have to go back to that initial data set. Okay, and you can see that the data set comes from sort of is related to paper. So let's cite that in the caption. Okay, and then give yourself some credit for making the chart as well. Okay, so we have 3 variables for our text. So we have our title, subtitle, and caption. Oh, fun. Let me see which one is. It's because this one doesn't exist. There you go. Make sure you run all of your code. Okay, so that adds our title and chart title there. Okay. We can also in here update our X and Y axes. Okay, so by default they are just the like variable names, which are not very pretty. Okay, so we can just put age in years. It basically says the same thing, but it just looks a little bit nicer, a little bit more professional. Okay, and on the y-axis, We can do average time spent indoors in hours. We can also update our legend title in the same place. Okay? So the way you access the sort of title for the legend is by using the argument that matches the thing you mapped it to. Okay, so if you remember, where are we? So way back here when we did size is equal to n, size is the sort of scale, the the aesthetic that we're mapping. So we can edit the title using that in labs. Okay, so we might just put something like number of cats. So that edits our axes and our legend title as well. So there's a few things again that we might want to fix with this chart. Okay. So first of all, we haven't yet we've added the fonts that we picked to the annotation, but the rest of the chart text still uses that sort of like default font. We haven't actually implemented that yet. This is quite a short subtitle, so it fits okay. It's running off the end a little bit. But if we had a longer subtitle, we'd have the same problem as we did with the annotation. Okay, and it would be like running off the page and get sort of chopped off. This legend is also taking up a lot of space. Okay, when we made the title longer, it's suddenly, you know, it's this really sort of wide space on uh, on the right hand side. Okay, so we maybe want to think about the position of that. Okay, and we can add our styling to get rid of that grey background and use our sort of desired background colors. So let's yeah, let me save that first as our sort of text plot. Okay. And then let's sort of fix the styling of that chart. So the first thing I'm going to do is use a different theme. Okay, so by default in ggplot2, the theme is theme gray. Okay. Let's be called theme gray because it has that gray background. I'm going to use theme minimal instead. It gets rid of that gray background and use these sort of light gray grid lines instead. What you can do inside theme minimal is set some of the defaults. So there's a sort of base set of uh, arguments. So you can set what's the base family. So that is what is the default font for all of the elements in ggplot2. So I'm going to set that to our like body font, okay, that Ubuntu one again. Okay, and you can see that that has now changed the font that's used for all of the text elements that are on the chart and that are controlled by the theme. I also think the size of the text is just a little bit too big here. So I'm going to reduce the size to a sort of base size 10. The default is 11, I think. Okay. And you see that just sort of gives everything a little bit more space and sort of better ratio of text uh, to chart space. Okay. But there's still some other things I want to change. Okay. So I want to change where the legend sits. Okay. I want to change the font used in the chart title. The other thing I want to change a little bit is where this title text sits. Okay, so it's one of the things that I find again a little bit annoying about the defaults in ggplot2 is that the chart title always aligns with the left-hand side of this sort of panel rather than the left-hand side of the entire chart. Okay, so what I'm going to do is I'm going to fix that. Okay, so let's look at theme. Okay, so you can start with a base theme like theme minimal and then add the theme function on top and just edit the little bits that you need to. Okay, so really kind of nice. It's a nice way also to build up your own themes. Start with something that already exists and then add all of the other elements that you need to change. So what we're going to do here is change the position of the sort of title and subtitle text. So I think there's something like 90 something arguments to plot. to the theme function. So it is quite confusing. So the one we want here is plot.title.position. Okay? And if you set that equal to plot, what that's saying is align the plot title, the position of it, with the full plot rather than just a panel. So if I do that, okay, my sort of chart text lines up in, I guess, a much cleaner way, in my opinion. And you can do the same thing for the caption, plot.caption.position, and you can do the same thing, and that aligns it like fully to by default to the right hand side of the plot area rather than just the panel. The other plot things, sort of text elements that we want to update is our plot title text. Okay, so we can do plot dot title. Okay, and most arguments in theme expect you to say what sort of element it is. Okay, so a plot title is an element text. Okay, so we're wrapping all of the arguments to plot.title into this element text function. So we want to set family is equal to the title font variable that we had. Okay, and that changes it to our sort of more fun or display font. Now, what we probably want to do is make that a bit bigger. Okay, it's a sort of title font, so we want that to be bigger. So what you can do is you could say like the size of that font I want it to be like 22, okay, and it would make it much bigger. The problem with sort of hard coding fonts like this is that if you then saved the chart at a different size, you'd have to go in and edit that font size. Okay? If you changed that sort of base size, you still have to then go and manually change this one and work out how much bigger should it be. What you can do instead is use the rel function, so REL, okay, and that sets the relative size to so relative to that base size of 10, how much bigger should the title text size be? Okay, so you might choose something like 1.6, so it's 1.6 times bigger. Okay, you go even bigger if you wanted to. Okay, but using that relative sizing when you're editing text elements is really useful because then if you change the base size and make it bigger, you can see that title text scales up as well. So you don't have to manually go in and change that as well. Our subtitle text is running off the chart area a little bit. So we want to wrap that. Okay, the same as we did with the annotations, or wrap that text onto another line. Okay, so what I'm going to do is the plot.subtitle, and I'm going to use the same, well, essentially the same trick I did with the annotations, and that instead of using element text from ggplot2, I'm going to use element text box simple from ggtext, and that's the only thing I'm going to change. And you can see that it now sort of aligns correctly. And if it was a much longer subtitle, let's just have an example, double the size of that, it wraps automatically. If we use element text from ggplot2, it runs off the page. So just that really small change from element text to text box simple, it makes your chart look much more sort of professional and easy to read. And we could do the same. You can apply element text box simple if you had a long title, or if you had a long caption, or you wanted to add some styling, some custom styling to your caption, you could apply that there as well. Okay. So I'm gonna save that there, okay, to try and avoid. In fact, let's just keep going. So what I want to do now is move that legends. Okay, it's currently outside the chart area. one thing you can do is set the legend position. Okay, this is something that's changed a little bit in ggplot2 since version 3.5. You used to just be able to put in a coordinate of where you wanted it to. What you need to do now is set legend.position to inside. Okay, and that by default sticks the legend straight in the middle of the chart, which is not the best place for it. So what we can do is say legend.position.inside, and then we put in the coordinates of where we want that to be. Okay, so an X and Y coordinates. When you're putting those coordinates in, they go between 0 and 1. Okay, so they're not based on the values on your X and Y axis. 0, 0 is the bottom left corner, and 1, 1 is the top right corner. Okay, so let's try and put our legend sort of over here, so quite far on the right hand side, so maybe like 0.9-ish. And for the sort of bottom right, we want maybe something about like 0.3, okay, like a third of the way down. Okay. So that puts our legend over here on the right hand side. Okay. And it is one of those things, if you're trying to position a legend inside the chart, it's going to be a little bit trial and error to get it exactly where you want it to. Okay. The other thing I'm going to do is add a little bit of a background to that legend box. Okay. So when the legend is outside the chart, it doesn't really matter what the background color of the legend is. But when it's inside the chart, um, you want to make sure that it's clear that these sort of points are part of the legend and not data points in the chart. And you also want to make sure that it's easy to read without those grid lines coming through in the background. Okay, so what I'm going to do is edit the legend background. So in ggplot2, that's going to be a rectangle, so element rect. Okay, and I'm going to say the fill is equal to our background color. Okay, but not a solid color. Let's make it semi-transparent so you can still sort of see the grid lines and things. And the color I'm going to add an outline is going to be the same as that text color. Okay. So again, you start to see the benefit of using variables for color names. Okay, you get that sort of predictive typing. But also if you change the variable color, this would just update automatically when you run the chart. You don't have to edit the code. Okay. So this is running off the page a little bit. So let me just make that a little bit smaller. Okay. So we now have our legend, okay, with a sort of semi-transparent background. It's really clear that these points are in the legend. Okay. So we have our sort of final chart now. So what we can do is we can use ggsave. Okay. And we put in our file name. Okay, so let's say cats.png. Okay, so the extension on the file name tells you what type of file do you want it to be. And we set our width and height equal to 6 by 4. So if you remember, that's the same settings we used when we set up camcorder to put things in this viewer tab. So if I run that, okay, you should see it here. And I'm just gonna open this up, hopefully. Just move this over. Okay. So what you can see, if I just drag it across.
Sorry. Okay, yeah, because I
Yeah,
was in this
yeah. Yeah, it's not exactly what you'd perhaps want. Okay. So because we're using theme minimal technically has a transparent background rather than a white background. Okay. You can't see that when you view it in RStudio because the background of the thing in RStudio is white. So one way of doing it is to edit all of these theme elements, okay, to make it white. A much easier way is to set this background in save. So what do you want the background color to be when you're saving it? Okay, and if we open this up again, just move across, there we go. It's taking its time. Okay, we now have that white background. Okay, so you can save it with white, okay, or you can save it again with your variable with that background color that's going to be slightly off white. Okay, so you can edit the background color of charts in theme, but you quite often, it's more about when you're saving it as an image that really matters, and this is kind of a quick way of doing it. It means you could put your plot on a different colored background if you needed to. Okay. So let's just finish up by jumping back to some slides. Okay. All right. So once you've made a chart, okay, it might or might not look a little bit like this. Okay, it's useful to kind of reflect on it a little bit. And it doesn't necessarily mean, go and look at all the things that's wrong with it and fix them before you share it. Especially when you're doing things like Tidy Tuesday or like map challenges, it's more about learning rather than making the perfect chart. But we can still have a little think about what would we like to change? So one of the things about this is that we've got a box around our annotation, which is made with ggtext, and then we've got this box around our legend, which is just made with ggplot2. So we've got these nice rounded corners, and then we've got this kind of default really square box. So it would just make it look a little bit nicer if, that styling was more consistent. Okay. We've also not really used all of the data. Okay, so we talked about this chart looking at the relationship between age and how much time cats spend indoors. We haven't used any of the GPS data. Okay, so if we'd used the GPS data, we might have been able to, add more information to this plot that kind of makes it more clear. And if a cat's just lying in the garden all day, is that really different to having time spent indoors? So if you wanted to keep going with this chart, I'll share all of the code that we've done so you can go through it. But what you could do is you could keep going with this chart. Okay, you could add some more annotations. Okay, and rather than just having an annotation sitting here, what you could do is add an arrow. Okay, that points, say this is the data point that this annotation relates to. We could use some of that GPS data. So we could join those two data sets together so that you can look up the GPS ones and then information about the cat it belongs to. Okay. We could look again at that speed data, that ground speed data. So it's very unusual data, but, or sort of maybe not very reliable data, but we could still look at it and see if that relates to time spent indoors. And we could add more annotations. Okay, so something like we've highlighted the oldest cat, which one spends, the most time indoors, or which one is the sort of fastest. So if you do want to go a little bit further with visualization in ggplot2, these slides are up online. So that's the kind of link to the website that has the slides on it. I'll upload the code that I've gone through today there as well, so you can download that as well. Okay. You could look at the ggplot2 documentation. Okay. It's the obvious advice that we all know we should take, but go and read the documentation for the package. There's also the ggplot2 extension gallery. So if you're trying to make a chart in ggplot2 and you think, you know what, this is like it's really tricky. I can't quite make it with just what exists in ggplot2 itself. There are lots and lots of extensions for ggplot2. It's one of the really nice things about it is it's very well extended. So you can browse through the extensions gallery and see, okay, actually what I wanted was some curvy text, or I wanted a different type of chart, for example. So something like GG Ridges, if you want to look at distributions for different categories, it's quite hard to do that in just ggplot2, but there are extensions for making lots of different types of charts. So do browse through that site to have a look at what you can make in that ggplot2 world. There's also the R Graphics Cookbook, which again is lots of information on making different types of charts. In R, most of the examples are ggplot2 as well. And have a look at TidyTuesday. Okay, so I think it's one of the most beneficial things that I've kind of gotten involved in with the R community. It's a really good way to look at a much wider range of data sets. It's a good way to just practice stuff and go make kind of charts that you maybe wouldn't normally make day to day. And you can go and see, because people share their code and their outputs, it's a really nice way to see how other people do things, but also what kind of charts do people make for the same data. And you can also go and read the book that has this example of cats data in it. In sort of chapter 7, it goes into a lot more detail on that. Okay. But I'm happy to take any questions if you have them.
Nicola, there is a question in the chat, which is about the size of the font. So I ran some codes, but I see that the font can be very large, larger than expected. This is a tricky that show text does. So how do we fix that?
So there's two. Make sure that when you're using the show text package that you set the DPI. So this, I set it to 300 here, and that resolution matches with the settings for camcorder and with ggSave. So those all match, but if one of them is different, so if you were looking at things just in the plots tab, the fonts settings for show text, you need to make sure those match up. So hopefully that helps. Okay, so there's another question about the camcorder package. So how do you get the GIF at the end? That's a really good question. So in the camcorder package, there is this one? Is GG playback. I always have this set up with my default settings. Yeah, so we run GG playback. We need to give it a name. Okay, so I'm just gonna do cats .gif. Okay, and then if you run that, it looks through the temporary file it created with all of the screenshots of those different charts. It resizes them to make them a little bit smaller. It also puts them, I think it makes them square, and then it joins them together in a GIF, and you can see it does take a little while. And it should open by default. Okay, so you can see all of our sort of chart getting built there. Okay. And one of the things about this is that when we start using theme minimal, you can see that like this sort of all disappears because of that transparent background. So there's arguments in here. You can see the default background is black, but what you can do is you can do background again equals background color, and it will update that. Likes to take its time sometimes. Okay, so you can see that like now you've got that background color, and you can see all of the edits that happen when we use the minimal and use a transparent background now. Okay, so that's how you get the GIF from the camcorder package. I feel like there was a question earlier on that I didn't get to. I think it was about fonts.
There is one about how to put the legend horizontal on top, like number of cats, 369.
Yeah, yeah, you definitely could. So rather than having the sort of legend within the chart, you could put it sort of as a horizontally along there. Yeah, definitely. It's quite a nice way. Again, it's where I think the default legend should be. It kind of takes up less space when you use horizontal ones rather than sticking them on the edge of a chart. So yeah, it's a good option if you don't, if you had data points everywhere and there wasn't space to put it inside the chart here, you could definitely put it along the top. That's a good idea.
Thank you very much for all of your nice words, and we look forward to seeing you all. So if you left, please do not miss an eye on our website. So we are going to post next event soon. Thank you very much, and see you all soon. Thank you, Nicola, for your wonderful presentation. Thank you again.